Hello there, Grade 8 CSS, and welcome to Computer System Servicing. Before we jump into our lesson, I would like to know your prior knowledge. Time's up! How many questions did you answer confidently? As we go through the lesson, you will be able to realize and provide clarifications for yourselves. So let's get going! Watch attentively to this short clip entitled Luggage Bag, the Evolution. Questions will be given after the video. Ready? Now let's process this. On the video, we saw three different kinds of luggage. One is hand-carried, the other one is a trolley bag, and the last one is a scooter bag. What do they have in common? Yes, they are all containers or storage of your personal belongings when traveling. What does the evolution imply? If you say something like its development, progress, it became modern, these are all correct. As the time passes, the storage bags or the luggage undergo progress, which makes carrying easier, from being hand-carried to having wheels to be pulled, and lastly, the scootered bag, which makes it faster for transporting and carrying your personal belongings even without actually having the weight of it. Same with the disk drives of your computer. They also went evolution, and the more modern ones seems to outdo the previous models of the disk drive. Let's learn how the disk drives evolve as we have a simple comparison on our lesson of the day. Our lesson of the day is Lesson 4, Comparing HDD and SSD. This is under the core competency, Installing and Configuring Computer Systems under the Computer System Servicing NC2 TVL Track Information and Communication Technology. Our objective for today's lesson is to compare HDD and SSD in terms of build, communication interface, form factor, speed, storage capacity, pricing, reliability and durability, noise, power consumption, and lifespan. But first, what are SSD and HDD? Basically, they are your computer's storage devices where you can permanently store your digital files and data. So without much ado, let the comparison begin. Round 1. Built. Inside the hard drive, there is a spinning disk called platter, where all digital data are stored magnetically. They are being read and written through the head. On the other hand, the SSD stored data in integrated circuits or flash chips, often dubbed as NAND. Round 2. Communication Interface. Let's compare SSD and HDD according to its communication interface. So what is communication interface? The communication interface is actually an electronic circuit usually designed to a specific standard that enables one machine to telecommunicate with another machine. It's like a specific shape of plug for a specific socket type. But this specific electronic circuit also influences the speed or the transfer rate of each storage device. Confused? Let's take a look at HDD's communication interface. The two types of communication interface for HDD are 1. The PATA or the Parallel Advanced Technology Attachment. For its communication interface, as you can see, it has pins. But since this interface can only transfer data at a rate of 133 megabytes per second, this one is already obsolete. Its connector was the IDE, and it was connected to the IDE connector on the MOBO. This was replaced by SATA. SATA provides faster communication interface than PATA, which can go up to 300 megabytes per second. It is connected through the SATA ports via SATA connector on the motherboard. SSD provides two types of communication interface. 1. The SATA, and 2. The PCIe NVMe. The SATA interface is more affordable, commonly found, and offers good performance for common application. Let's take a look on the different communication interface of SATA SSD. 1. We have the 2.5 SATA, which is similar to HDD's SATA, but the transfer rate can range up to 550 megabyte. Next is the M-SATA, and lastly, the M.2 SATA's transfer rate can reach up to 6 gigabytes per second. On the other hand, the PCIe is the standard interface for NVMe, which is 3 to 10 times faster than SATA SSD. NVMe is much faster because it provides more bandwidth than SATA models, which improves performance in heavier productivity applications such as video editing. The communication interface under PCIe NVMe are U.2, which can send data up to 4 gigabytes per second, NVMe M.2 SSD have theoretical transfer speed of up to 20 gigabytes per second, while the HHHL or half-length, half-height can go up to 32 gigabytes per second. Round 3. Form factor. Take a look at the moving image shown. What can you say about it? If you say something about the size and shape, it's correct. The form factor is the physical size and shape of a piece of computer hardware. Let's begin with the form factor of the HDD. The two most common form factor of the hard disk drive are the 3.5 inches, common for desktop, and the other one is the 2.5 inches, common for laptop. So there, you can see the difference between the two form factors of HDD. On the other hand, SSD offers many types of form factors depending on their communication interface. So let's see the differences of their physical sizes and shape. We have the 2.5 inches, M-SATA, and M.2, which falls under the SATA communication interface. We also have the U.2, M.2 NVMe, and the HHHL or the AIC, which is under the PCIe and VMe communication interface. Round 4. Speed. Now let's watch this short clip and you decide which device is faster in terms of booting and opening an application. Obviously, SSDs outspace HDD. This is because they use electrical circuitry and have no physical moving parts. This leads to shorter wait times when you're starting up and fewer delays when opening apps for doing heavy computing tasks. Round 5. Storage capacity. Now, when we talk about storage capacity, this is your computer's ability to hold as many digital files as it can depending on its capacity. Now let's compare them according to their storage capacity. When you go to a market, which do you prefer? A basket or a pushcart? Perhaps some say it's the basket because you do not have much to buy. But some would say it's the pushcart because it can carry many groceries and it even have wheels. When it comes to capacity, HDD can go anywhere from 250 GB to 20 TB, whereas SSDs are available in 120 GB to 30.72 TB capacity. Round 6. Pricing. Of course, you can have a fast and good storage disk, but take note, it's not that cheap. In terms of pricing, you cannot have it all. SSDs are more expensive than hard disk drives in terms of dollar per gigabyte. 1 terabyte internal 2.5-inch hard drive cost between $40 and $60 as of 2020. That translates into 4 to 6 cents per gigabyte for the hard disk drive versus 10 cents per gigabyte for the SSD. Round 7. Reliability and durability. Which among them lasts longer? Since HDD has a rotating disk, its platter is prone to damage due to accidental drops, vibration, and shock. It's prone to extreme temperature due to the continuous and fast rotation of the disk. It is also prone to damage caused by magnets due to its magnetic field. On the other hand, SSD doesn't have moving parts, and all its NAND or flash chips are all intact. So who wins in terms of reliability and durability? You know the answer. Round 8. Noise. Let's hear about noise. Hard drives have moving parts, and when things move, they often create sound. Let's watch this short clip. On the other hand, SSDs make no noise at all. They're non-mechanical. But, do some SSD have sound too? Let's find out. How does this happen? When a specific voltage is applied to SSD components, they begin to resonate, producing sounds that fall within the range of human hearing. The noise is generated from the processor's power circuit. Round 9. Power consumption. For power consumption, this short clip shows how HDD consumes electricity than of an SSD. An SSD doesn't have to expend electricity spinning up a platter from a standstill. Consequently, none of the energy consumed by the SSD is wasted as friction or noise, rendering them more efficient. On a desktop or in a server, that will lead to a lower energy bill. On a laptop or tablet, you'll be able to eke out more minutes or hours of battery life. Round 10. Lifespan. And lastly, these are the key points to consider about lifespan. With regular usage, solid-state drives usually last about 10 years, a lifespan that rivals your typical hard disk drive. This wasn't the case, because the cells in a solid-state drive can be written to and read from only a finite number of times. By contrast, HDDs have a theoretically infinite read and write capability, assuming that the mechanics inside are still functioning properly. New technology like wear leveling has improved SSD's life expectancy to where it is today. While SSD memory is still constrained by a finite number of operations, the device have improved so much that the whole computer will need to be replaced long before that capacity limit is reached. And crucially, SSDs have no moving parts, so you do not need to worry about mechanical failure. Prepare your pen and paper and let's get your brain working. Let's have your summative evaluation. Activity 1. Identification. Direction. Identify what is being described in each statement. Refer to page 28 of Quarter 3 CSS 8 module. Time's up! Remember guys, how much knowledge you gain depends on your willingness to learn. I hope you learned from today's lesson. God bless!